Good morning, my dear students. The last class we have discussed about distance and displacement very clearly. So now we are going to discuss horizontal directions. Since displacement is a vector quantity, we have to mention the direction and what direction it is. For that purpose, we are going to learn the directions, and these directions are also used to locate the position of object on the surface of the earth. Suppose you are standing in your home and facing one of the wall. You will say some objects are to the left of you, and you will also say some objects are to the right of you, and some refrigerator, washing machine or something is behind of you, you will say. And when you change your position, like you change your standing position or sitting position, again the objects which are to the left, right, back and front will be changed. That's why, so the left side of you is something is not an exact what is the meaning. So we have to go for the directions. There are 8 basic directions which we are going to learn. On the earth, the directions parallel to the ground, which are assumed to be the flat, are called horizontal directions. So when we know that sun rises, we know that sun rises and sets every day. Sun rises and sets every day, and if we stand facing towards the sun, that direction is taken as the east. The rising of the sun is taken as the east, and the exactly opposite of the sunrise is called, what is that? Exactly opposite direction to the sunrise, that is called sunset. The sun is setting in the west, we will take that. And if we stand facing the sun, so our left hand side direction is taken as the north, and the right hand side direction is taken as the south, and which all are taken on the earth. The directions are taken on the earth parallel to the ground or parallel to the floor, and which is a flat. So which is flat. So I am representing those directions here. You see, children. So if I stand facing the rise of the sun, then so the direction in which the sun is rising, that is we have taken as the east, and the direction, the location in which the sun is setting, we have taken as the west. And while standing facing the sun, our left hand side direction is taken as the north, and the right hand side direction is taken as the south. That is, on the surface of the earth, the rising sun position is taken as the rising sun position, we will take it as east. So, and exactly opposite of east is called, what do you know, my dear students? West. So that is, sun sets in the west and sun rises in the east. And in that flat horizontal surface on the earth, in the flat horizontal surface, if we stand facing towards the sun, so our left hand side direction is considered as the north, and the exactly opposite of the north is called south, which we have to take on the ground on a flat horizontal surface. On a flat horizontal surface. On a flat horizontal surface we will take. Okay students, now see, so this north, south, north, east, west and south, or so these are taken as, okay, these are generally called as, you can remember it is also news also. So N stands for north, E represents east, this is east, you know, and W represents west and S represents the south. So fine, these are the basic directions, and if anything is exactly lying between north and east, it is called northeast, and anything lies between north and west, exactly lies between north and west, then this is called northwest, northwest, and this is called as northeast. And if anything, any vector quantity which is lying exactly between south and west in a horizontal plane, it is called southwest, southwest. And if it is exactly lying between east, so south and east, then this is called southeast. Like these are the 8 basic horizontal directions we have, so to locate the position of the object, and these are called horizontal directions. So these are called horizontal directions, horizontal directions. Okay students, and if you take a square, if you consider a square here, exactly at the corners, see for this, and we know this is east, exactly opposite of that or behind of that is, we know that west, and now this is north, and opposite to that is called south, and these corners of the square, so this is northeast, northwest, then this is the corners, and this corner you have southeast and southwest. So these are exactly lying. So if any vector quantity or anything, if it does not exactly lying, if it doesn't exactly lies in the northeast or the southeast, then how it will be represented we can see now. So see my dear students, now on a flat horizontal surface I am taking map directions, so that is, this is we know east, west, north and south, you know. Now something is represented like this, and it is making an angle of 30 degrees, so which is not exactly lying. So exactly means it should be 45 degrees, you know. So if we consider, we know that. So for this, how do we say the angle? You see my dear students, how do we say the angle means, it is making an angle, that representation is 30 degrees due to the its representative. This is called example 1 also you can call. So this is example 1, you take it. So here it is, this is some displacement. This displacement is lying in northeast, but it is not exactly lying. So you cannot say, then we can say it's an angle like this, 30 degrees due north of east. You can say it is means with what direction it is making angle, that should be at the end. See, it is lying in north and east. It is lying in between north and east merged is there, and so you are writing northeast. So it means it is making 30 degrees angle with the east. Or the same thing I can consider with this 60 degrees. Then I can write it as 60 degrees due 60 degrees due. Okay, what is that, children? East of north. So we can write it as 60 degrees due east of north also. We can represent this. So with whom it is making angle, that should be mentioned at the north final. So it is making an angle of 60 degrees. It is lying in east and north merge and making an angle of 60 degrees with the north. Or you can also say the same thing is making an angle of 30 degrees due to the east. And now we can see 3 more examples very clearly. So fine. Now see, my dear students, second example. So I am taking example 2. So now this is a vector, this is some displacement, and this angle I gave for you 30 degrees. We know this is east and we know west, north and south. Then it is making an angle of, see, it is lying in east and south merge. It is lying in this region. Okay. With whom it is making angle? So, see, we will say that 30 degrees and lying in south and east, 30 degrees due south of east, because finally it is making an angle with the east. So you can say that it is lying in south and east and making with the angle east, 30 degrees due south of east. You can decide it. And I can take one more example. So now another example. Example 3, you see, students. So now this is and now it is lying here. This is the vector line. So vector or physical quantity. So east, west, north, south, and it is making an angle of 45 degrees. So I gave it for you, making an angle of 45 degrees, and we know that is 45. This is also 45 degrees. Then total will become 90. So it is exactly middle of the north and west. So simply we can say that given vector is in northwest. So given is in northwest, directly you can write northwest. So northwest you can say, that's sufficient. Northwest means it should make an angle of 45 degrees to west or 45 degrees to east. Or if you want to write it, so 45 degrees due north of west you can write, or 45 degrees due west of north also you can write. Anyway, it is making equal angles with north or south. So you can simply say that is lying in, so the given vector, the given displacement, some OP bar if I call, this is the initial position and this is the final position. then the displacement OP bar is lying in northwest. It is sufficient. This is sufficient for you. It is simply lying in the northwest, means it is exactly in the middle of the north and west. It is sufficient for us. And we can see another example. If some quantity lies here, like making an angle 60 degrees, then we say that it is lying in west and south and making angle with south. So you write like this, students. It is lying in west and south. So west of south and with the south 60 degrees. So 60 degrees due west of south. This is the fourth example we can mention. So sometimes the vectors lying in the plane will be represented like this. And my dear smart kids, don't get confused that north means we should not look up and south means we should not look down. So this north, south, east, west will lie in a horizontal plane only. They will lie in the horizontal plane. Vertically up means you have to see up. And from your reference horizontal flat surface on the earth, something is down of that horizontal plane, you have to say vertically down. And don't get confused that north means upward, south means downward. So no, north means if you stand facing towards the sun, the left hand side of you is the north and the right hand side, exactly opposite of that is right hand side is south, and back of you is the west and the front of you is the east. So the sun rises in the east and sets in the west, we will say. These are the horizontal directions. Thank you.